Hi, today we'll be starting a new project. I wanted to do something like a small game from kind of from scratch. No hard rules like have to do everything. I can use some libraries, but mostly I wanted to get into the process of making a very basic engine, 2D engine, um, using GLFW. I will be using a different graphics API, so not OpenGL. I'll be using WebGPU, which you can get here, the native version. I use the Rust one from the GFX RS guys. And I'll be using the Scopes programming language to program this, which is a systems programming language. It's not very well known, but it's what I like to use. And if you want to follow this along with C or C++, you're probably gonna have an okay time because the APIs that I'm gonna use are largely C-based, so that's not really too big of an issue. And I wanted to get into the very start of the project, so here I have the project folder, not even anything yet. I did download previously the WGPU binaries, so I don't have to wait for anything even though it's small. Let's make a new folder. It's going to be a shmup, shoot 'em up game. And I'm going to drag this here. And let's extract it. Okay, let's rename it to WGPU. And today I want to set it up, get it working, and maybe even the classic triangle for the graphics. So for that, I would have to initialize WGPU and get shaders working. So that's the graphics basics. And then in a later episode, we can start working on some basic gameplay. Let's see. The first thing is a main file, set up our build task on VS Code. I should probably increase the font so it's easier to see on video. Yes, this is fine. Okay, now that we have this, let's make a build task. I already have scopes installed on this machine. You would have to put in your path. I have it built it myself, so this is a more or less bleeding edge version of the language, since the latest release is like from 2020 July. So that's what you want. So it's called main.st, right? I think it's called build task. Working. I think, yeah, this should work. Let's try. Okay, it works. So now that we have this set up, I can use a very quick shortcut to run everything. Okay. Here we have, for WGPU, we have the shared library and a header. I will be using this header as reference. I don't want to be going to Firefox all the time. So yeah, I'm gonna close it actually. It's gonna be fun. So this is how I normally work with it. There's not a lot of good reference, like there's the specification, but it's written for JS. It's not very useful if you're doing native. I mean, it's sort of useful in that it kind of explains what every function does, but it's not really that good. So at this point, I have enough experience with it that I can just look for the function signature I want, and then I can deduce more or less what I have to do from there. So, okay. What I like to do in this kind of project is to make a runtime file that loads my libraries. So, load library. Let's start with libtlfw3.so. I think this works. Sometimes I want to run a specific file, so I have to go here, runtime. That didn't work. So I think it's this, plus 3 into good measure. No, okay. Let's see. Oh, damn it. I always forget what's the, oh, that's a typo. Come on. Okay, it works. Great. Another one's gonna be the WGP one. It's called Lead WGPU native. Okay, so that's basically what we need for now. Later, when I add audio and yeah, I think that's basically it for external libraries. Other than that, not like shared libraries. I would use libc, obviously, since mostly Scopes doesn't reinvent the wheel when it comes to things that you can do with libc, so I'm gonna use that. So all right, here we have it. Now we need let's open a window. Maybe first things first, we gotta import a runtime. So basically what happens here is I import this file, it's executed, it loads these shared libraries at runtime, and then it kind of works as if I had linked them. It uses the LSIM in the background, so that's fun stuff. Okay, and then we have what window close. Oh yeah, I had to import the GLFW headers. Okay, let's create a new folder called FFI, and here, new file, GLFW. Let's see. Now, instead of doing this from scratch, I'm going to steal some code I had previously to do this. Even though I said it's from scratch, I don't want to lose a lot of time with very menial tasks. So I have this down here. It probably uses some, oh no, not this one. Let's see another product. Sometimes I do some experiments, so that was one experiment. It doesn't look nothing like what you usually use. This is more like it. Okay, we have this. Okay, and now we have this filter scope function that I need also. And I think I can just copy this file, yes. Okay. FFI output. And I guess I should maybe explain what's happening here. Let me just finish this. Import. So basically what's happening here is we're importing a header. Scopes has this this function to include a C header, which you can use to, I don't use this because in that project I have it locally, but this I'm gonna use in the system libraries. So, okay, and here what it does is it prints the start namespace of the name of the function. So instead of having to type glfw.glfw with window, I just take this part out and I have just the prefix in the namespace, right? So this is what this is doing, some namespace manipulation, which I could explain at another time, but not. We're gonna import that. Something else. It's probably gonna get Wgpu as well, which I have here. And I think I don't use anything special here either. So, okay, great. I just have to figure out the path, and that should be fine. Same thing. There's a bit of some fixes because some things are kind of annoying, and since I have used this library before, I've noticed some few problems. For example, in scopes, enums aren't set to 0 by default. So here I set this the constructor to 0 by default, and yeah, that's mostly it. Previously, I had some other fixes, but since the library has been evolving, they have taken out some of the stuff that was painful. So now I can pretty much just import it and it works. So here, I don't need this thing actually, I think. Let me see if I can just comment it out. Fine. Oops. Doesn't work. But you can find it. Oh, so it should be. But I'm gonna be loading this from. No, this is safer. I can import it relative to the directory in which the module file itself is located in. So if I use this module thing here, it doesn't matter from where I launch the program, it's gonna find the header regardless. Okay, let's do it. It should be one level up, and that's it. Let's try again, and it works now. Great. All right, now that we have, oh, and I should join these two. WGPU. Does this work? Oh. Did I not import the thing right? Did I not say the thing right? Should be using. Yes. Okay, everything works. So that's basically the setup for the project, I think. For as long as we're going to be running the code directly through the online compiler, I don't need to do anything special. If I was, yeah, at some point I'm going to add binary dependencies that I need to build. So at that point, I'm going to write a script, nothing too complicated. This project is supposed to be as little brainwave spending as possible. So everything we can do on the spot and in the simplest manner possible, that's how I want to do it. So, okay, now that I have the basics, I said I wasn't going to use Firefox, but I probably will because I don't have the whole GLFW API memorized. So I take that back. Yeah, that's gonna GLFW. Okay, documentation. Oh, here's a very simple example, great. So we have this. Variables in scopes are auto-typed, so I don't need to bother with the whole LFW window stuff. Although this might need to be mutable. I don't remember. No, it doesn't, so I can just return it like that. Okay, so we need a size. Let's do it 800 by 600. Call it my little game. Okay, no, no. We don't use commas actually. I've been programming a lot in Lua, so I've forgotten a few things. But yeah, yes. Window is no. Then permanent. And it uses uh, some OpenGL stuff that we don't care about. Oh yeah, I guess in this case I need to do some Wgpu specific stuff, but we can worry about that a couple minutes from now. Let's just try to get the window going. All right. While not. Let's try this out. And it didn't work. Oh, because I didn't call init. Yeah, for sure. I've done this enough times to know the point of failure. Okay. Okay, here. Yeah. No, it doesn't do it. And here we have it. We know. And it kind of works, except we don't have graphics yet. So now this is going to be a bit tedious because WebGPU is like the middle ground between OpenGL and Vulkan, so it's going to be a bit of setup, but bear with me. It's going to make a file called graphics. That's how I spell graphics. And here, let's do, or maybe, yeah, let's do it this way. And this is going to be graphics. I'm going to steal more code. Mostly, that's a very small thing I want to steal because there's some specific platform-specific code to initialize with GLFW that I don't want to have to do research right now. So I promise I will stop stealing code from old projects as soon as the first hurdles are gone. So, okay, graphics, I have WGPU, and I think actually the code one's not here. It's gonna be window. Yeah, this is what I want. Okay. It's gonna copy everything. Let's make a window module as well. And what this code does is, it says here in the comments actually, it gets native information about the window, so we can pass this off to WGPU, because compared to OpenGL doesn't handle surface creation. Surface is the buffer, let's say, that the graphics API renders to. And OpenGL lets the window manager or the window library do with everything, while WGPU and Vulkan, it's the new paradigm, they like to request some basic info from the window library, the window layer, and they themselves manage the surface. So for example, this means that WGPU and Vulkan can more directly manage things like what GPU you use and whether vsync is on or off. So like the whole presentation part of the surface is managed by the graphics instead of by the window library. So that's useful for us actually. So here, this is actually Firelink platform independent already. So I could use this on Windows. I will be focusing on Linux for a while, because to save time really. This code is from a framework I am writing, so it's more generic, let's say, but you don't need much of that stuff. Let's just focus on the simple things. Oh, this here is outdated. This is using the old API. I'm using the new one that they unified with the thing. I wonder where I guess I have to do some work here actually. Maybe I'll recut this out. I don't know. Okay, let's see. I have more code here that I can steal from. Here, render. Okay, let's open this here. Steal more code. Yeah, here it is. It's even more complicated. I don't know why they changed this. It was so good. And then they were like, no, let's make this more complicated. Okay, so let's yank this out because it's useless and get the new stuff. And I think with this, I don't have the, or do I? Oh yeah, I kind of unified the whole thing in a single function, I think. Did I? No, I need the other function. Where is it? Oh, it's window now. Window. Oh, it's in here. Oh yeah, because this other part of the code is from LFW. So this part's still useful, I think. Yeah, this part of the code is still useful. No, not this part. This part of the code is still useful, I think. Yes, because it's GLFW specific and that didn't change. This part changed, so we're yanking that part out. Okay, so I'll be in window. It's gonna be a mess at first. Some code in Windows, some code in the main stuff. I will refactor this later. Don't you worry. It's all right. This probably works. Let's hope. So, okay. Init, init. And here's that basic creating module stuff. We return the init function we export the init function. Okay. We have JFX, we have window, and that's probably all the code I need to steal for now. If I need, I will go back and steal more code, but for now it should be fine. So, okay. So we have code to create a surface and we have code to create a native window. And the first thing we need, let's make a state strip. Plain struct prisms, and we need an adapter. Wgpu. Let me get the let's start with a device, I guess. Okay. So to clear the screen, which is the first thing we're gonna do, I think I might not get. I have like 10 minutes, so I'm not gonna get to the triangle just yet, because that's the time I have for recording. Unless I record more today and I squish into 2 parts into a single video, but I don't know. Maybe I'll milk the second video and make it easier. So okay, let's change the goal to clearing the screen, which is surprisingly difficult, as you see. So okay, we have a device. What I like to do is to start from the end and then walk backwards from there. Okay, let's have this. And in main, we have okay. So by the point we make this work, the whole structure of the things in place. So it will clear the screen to a nice dark gray color. So, or I guess I can do it color here, clear color. No, I don't like that. Let's do it like this. Is that? I think that's I like. Yes, I have a favorite clearing color. Okay, so we're gonna get a color that's fairly similar to the background here, which might not be super noticeable. I guess I will make it white for starters. Yeah, let's make it white, just so we for sure know it's working. Because if I do it right now, things don't work, obviously. Let's see. Oh, because I did it wrong. Side WGPU. Same thing here. Now it should work. Okay. So this is the default color, nice black, and we're gonna change this to white. Okay, so here we need a render path. We need a lot of things. But the basic thing to get a clear screen is a render path with a color attachment. And the color attachment is the frame buffer of our window. I don't know if they call it frame buffer, it's like the surface. Okay, so let's start from there. Let's see. Render path thing. Am I on the wrong? Yeah, I am on the wrong header. Yeah, we want this header. That's why I wasn't finding the thing. Okay, now we're talking. Create render path. No. Close this. See more stuff. Command Encoder. Begin render path. Okay. So we have RP. Wgpu, Command Encoder. What's a Command Encoder? Who knows? They didn't run the path, but that doesn't matter because we just do the path backwards and we get it. So it takes a Command Encoder, CMD encoder, and I'll run the path description, repeat S, and that's all. Post up. So okay, and now we have in path to finish it, and it returns void actually. Okay. Run the path encoder on path, and that's what we should pass in, I suppose. Yeah, because the win on the path returns when the pass encoder with our RP, and then we pass it back to render path. Okay. And then we have something like Q submit, which closes the thing out. So like this is like submit this frame, right? So that's really the end of this stuff. It's probably a bit confusing the way I'm doing this right now, but as soon as we stitch things together, it will make sense. But that's basically my process of exploring this kind of API. I go backwards from the end until I find the beginning, because this stuff is the comment chain of this stuff is so long, so complex. So it's like there's no use memorizing this stuff. I'm gonna write this code once and probably barely touch it. I mean, sort of, part of it's not gonna be touched, but it will be modified. But like, you don't need to remember all this stuff. You just need to either follow a tutorial or do what I'm doing right now. But of course, I know a lot of things that help me know where I need to go, so it's not completely fair to say that's like you need to know a few things, of course. So do we have a queue? We don't, but I believe let's pass 0 commands and a new comment. New, how do you say no comment, no comment buffer. So queue, what queue do we have? We don't have a queue, so let's get a queue. Queue. Let's see what returns a WGPU queue. Proxify get queue. And it takes a device, which we have here, kinda. And internal state. So we're gonna fill this in here, but for now, we're just creating a scaffolding, so it's not super important. Okay, yeah. So okay. So I know for a fact we need the Command Encoder as well. So let's get that. Here, looking for create Command Encoder, of course. How could I forget that? Here. We do this at the beginning, if I recall correctly. So beginning of the, we have to do this every frame, by the way, because they're like ephemeral structures. They're done within the end of the frame. Device create Command Encoder. So a device. Descriptor. So, thing. Yeah. So, call it Command Encoder, right? Okay, after we have this, Command Encoder, begin render path, and then we need to end the Command Encoder to get a command buffer. Yeah. Command buffer. I wonder because no, I think we need yeah. We need to finish the Command Encoder regardless if we're sending commands or not. Okay, even if it's empty. So we can pass no here. No here, I think. So command buffer from the function command encoder finish. I like how everything has a different nomenclature to it. Very special. Like one thing you end, the other thing you finish. Maybe you destroy something else. I'm just being smart. But there's worse out there for sure. Okay. Yeah, here we go. Command encoder finish, and it takes a command encoder, but not call that. I think I made a mistake there as well. Command buffer descriptor. Lots of descriptors. Very descriptive. That's it. I think that's the basics for a frame. If we need something else, I will find out soon enough. CMD encoder, I think. Yeah, here. Great. Okay. So now that we have this, let's write the descriptors, and then we have even more stuff that we need to do. Let's start with the render path encoder descriptor. I would use this to rpdesk. I think rpdesk probably needs to be mutable. I don't know. Underpass descriptor. Okay. This is what I'm gonna do. I need more space because this is terrible. No, actually, I think I can do this right this way. Okay, much better. More, kind of much better. I wish I didn't have this minimap thing. Okay, run the task descriptor, takes a label. This is for debug stuff. When you go into render doc, you're gonna see this name show up. And color attachment count. This is gonna be 1, I believe, just the surface of the window. Color attachment is like the an output, let's say, where we're rendering to, right? So in this case, we want one for the screen itself. Let's call it that. And then it wants the color attachment itself. What's the name? Color attachments. Since it's only one, let's take advantage of the fact that C doesn't differentiate between an array and a pointer. So pointer to a single thing with a count of 1. Can't know the difference. Color. I don't remember if we have to create this or this is like provided. We're gonna find out as well. And then no stencil attachment, we're gonna skip that, and no occlusion query set. Okay. And now we need our color attachment. How do we make one of those? Oh, it's a struct. Okay. Texture view, Wgpu, run with past color attachment view. Result target, we don't need that yet. That's for MSIAA, which we don't use yet. Load OP. I think this can be default, both ones. I will look this up later. And color equals okay. Now this, the way we get this is via the next blockchain something. Only I had more horizontal space to work with. Get current texture view. Okay. This is something I happen to remember. So what this function does is it requests the current screen surface. So for example, if you're doing double buffering, you're going to have 2 of these that you alternate. So if you're doing double buffering, you're going to have 2 of these that you alternate. So one frame you're going to get one texture view, the other frame you get another texture view, and so on. And whenever you resize the window, these texture views get destroyed and remade. So if we don't get a different one every time, we're going to have issues. So that's why we need this function. And because there's the whole recreation thing, we're going to do a thing where if we don't get a good one, we don't render this frame. So for example, if we're resizing the window, it will skip some frames and so on because it won't like if you try to render with a swap chain texture view that's not ready. If you don't understand what swap chain means, it's this thing where it keeps swapping these buffers. And we will have to make one as well, but we can pretend it doesn't exist yet until 5 minutes from now. So, oh yeah, and that's also how you put things on screen. You call swap chain present. I almost forgot that. For sure, we're gonna get a black screen and be like, why? So swap chain present, swap chain, not confused with blockchain. Yeah, and here call it frame. Let's call it this, whatever it means. Difficult to name these things sometimes, because if you get the name wrong, the police comes to arrest you. So get current texture view. And I believe that we can check if this is good or not. It's a pointer, I think. Import, yeah, it's a pointer, it's a paid pointer. So I think we can do this. So we just don't render anything this range. Right. So we have a command encoder, we have the whole swap chain thing. Okay, so here we get our image. We have a color attachment now. Okay, now we need the command encoder descriptor that we called cmd enc desk. Yeah, we need this to be a pointer, so we have to do it okay. Same here, I think. So what does this guy have? A label. Great. Couldn't be easier. Very good name. And here we use a comment bar for the descriptor as well. Yeah. Okay, I think this part is basically done. Now we have to fill the gaps with the I state things and the swap chain. Yeah, yeah, it's not so difficult after all. Okay, so now we need a device. How does one create a device? Good question. Request device callback. WGPU chapter request. And it seems to get a device you need an adapter. What's an adapter? I also don't know. I know the device is like a logical representation of your GPU, and the adapter is a logical representation of your GPU. I don't know. I couldn't get a straight answer on that, but you need both things. And I think kind of a dummy thing now, I don't remember. It used to be that you need to make an adapter, but now I'm not sure. I think they just give one to you. Uh, yeah, like there's no function to get an adapter, I think. Like how do we even make one? Oh, there is a request adapter. No, there isn't. I don't think you can make an adapter. So like just skip that. Okay. Mm. Mm. Here it is. Proc instance request adapter. So I was talking shit. You can actually carry an adapter. Right. Here. I am scared. I think you need to pass in a callback, and in the callback you pass in the adapter itself. So also wants an instance. But I don't have one. We're gonna have to get one too. Why does it want so many things from us? Options, the options, and a callback and user data. Mm. And as user data, we're gonna pass in the pointer to the adapter itself. This is supposed to be asynchronous, but as far as I know, it completes exactly as you pass in the callback, so there's no use in doing the whole async thing. It might break in the future, but for now it's safe, as far as I know. Okay, so we have this callback here. It takes a result and user data. So we can do this like That's our code. Okay, now how do I get an instance? Create instance. Okay. I think this changed a little bit since the last time I used it, so that's why I'm a bit confused. Instance descriptor, and that's all. And it's nothing, actually. There's a lot of those things that are here, like as placeholders, but that do absolutely nothing. Or like, yeah, we need a descriptor, but what you put in it, you know? All right, at least less work for us, supposedly. Okay, now I have an instance, I have an adapter. I don't think I need to keep track of this instance at all because it's never used again. So let's get with files. I think we might not even need the adapter either, but I'm gonna keep it for, it may be useful to get like GPU info or whatever. So we're gonna keep it. One thing about this instance thing and adapter thing is that I used to be able to choose between a low power and a high performance GPU, and some time ago I tried this again and it wouldn't let me choose. So I don't know if we got this back since I last looked, but I'm gonna find out as well. But for this project, I'm gonna be sticking with the low power GPU, which is the Intel integrated graphics. Since it's a simple game and wasting energy is bad. But sometimes Intel graphics have trouble with Vulkan drivers, so if we things start to happen, we might have to force it to use my NVIDIA GPU or whatever high performance GPU you would have. Usually it's a dedicated GPU. I think they have some heuristics to determine which GPU is which, because in Vulkan, there's no distinction at all. They just give you a list of GPUs and information about them, and you decide which one you want to use. So like people will write code to decide which GPU is more powerful and then choose that. But some programs like to give you a drop-down list of GPUs to choose, which is pretty good. I really like that. Saves a lot of time. Okay, request device. It's pretty much the same thing as the adapter. We pass the adapter, a descriptor. Oh, this is different, I think. No, it's not. It's completely empty. Oh, we didn't do the adapter options actually. Let's do that. Surface. And I think this is where our create WGPU surface comes in that we get from GLFW. let's get back. Yeah, the only thing is compatible stuff, which comes from window dot create WGPU stuff. I don't remember if it takes like a, oh, the thing about this function that I'm pretty sure, yeah, I need to edit this to work as well. Because like it assumes you already have a window here. Yeah. This kind of bit of message in the code we copied from earlier. And now I have to do something like, right, I need to do all this stuff in the in here. I'm gonna clean this up later. Now let me see if it even runs like this. Yeah, wrong name. Types are a bit weird in this because of the capitalization. Not even import this. Mm, yeah. I usually do this. Mutable like this. Does it make any difference? Oh, I didn't call init again, but it works. Okay, things still work. So now that I did this refactor, things still work. Good. More cleanup to come later. We're gonna move this to window as well. Or will I? I think I will. Yeah. I mean, the main loop can stay here. I need to call window to know if we should close and automatically call poll events, or it could be like prepare frame or something, a function like that. Okay. Now that we have this compatible surface, this works supposedly. Better options, instance. Now we're getting the device, right? Filter. And a callback. Anything over that. You said that exactly. If it doesn't work with imply, we might have to do forced cast, but that's fine as well. Mm, device instance. Oh, we need the. No, we already have this. Now we need to create a swap chain. That's the thing. And it might just work. Oh, we didn't make the. That's nothing as well. Okay. Swap chain, create swap chain. For this, since we kind of need to make sure the swap chain is recreated whenever necessary, we're going to make a function for this. I guess you can just assign to the global state. I don't care. Swap chain equals view device swap chain the device surface. Ah, I guess I need to save the surface as well. swap chain. Okay, takes a device, takes a surface, takes swap chain descriptor. Get the big list of it, right? Oh, I use capitalized C. I think there's a difference. I think in Vulkan they use swap chain as a single word, and that WebGPU for whatever reason decided that they're two words. So if you're going there and back, you're gonna be confused by that. Descriptor. Oh, this one takes a lot more stuff. I think I can just get this information from window. So, okay. Window.getSize. And here we're gonna have like label my swap chain. I really don't need to put these labels, by the way. Unless, but like, why not, right? Usage flex. Non-copy SRC render attachment. I think this one is render attachment because it's like the swap chain thing, right? If it's not, we're gonna find out as well. Now, did I do this right? In that it, let me test this actually. Oops. What I want to know is if how do I use this name? Because in C you just use this name, but since we're using a namespace, I don't remember if I cut this part or what did I do. WebGPU.texture usage. Yeah, I did it right. So like I have both the complete name and the like shrink name or trim name. So like here I'm gonna use render attachment supposedly. Yeah. Okay. This few things like quality of life things for when you import a library. You got to do something to make it more easier to type because WebGPU is a lot of typing, so you don't want even more iteration from a badly wrapped library with this. Okay. Okay, we have usage format. I think it's gonna be PGRA a unorm as RGB. This is just something I probably looked up. What was the good format to use? You can actually query this to know if this is the right format. I don't. I know this almost. I know this pretty much always works. So I won't do the check right now. But if this was more of a thing that I need to ship, then I would do the proper check. And maybe I will later. But for now, I just want to get this done quick since the video is rather long already. Okay. Nope. Format with height. That's the window size, since you have to create the surface and the exact size you need. And present mode, this is kind of like vsync. Um, immediate would be like no vsync, mailbox is weird, FIFO. If I recall correctly, it's kind of like vsync, so we're gonna use that because I like it, I guess. What was the name? I think present mode is. I can probably make an option setting that you can change this in game as well. Oh, first 32 is just like the max value of the genome. It's not really a thing. Okay, present. So here's everything we need. Quick swap chain. And here, if it fails, we want to quit the swap chain. Now I need the get size function. What's the function for that in the window guide? JSR will get window size. Yes, that's like exactly like how you do it. And then we return this guy. And now I need to export this, organize it a little bit. I will change the name of this later because I can like window.window. Okay. Oh, we never did the instance task. Hmm. Oh, typo. Equate swap chain, not in scope, because I need to put it higher. This is not one of those languages where functions are accessible from everywhere. And course value, swap chain desk. No, it's just type checking really. It's supposed to be a pointer. Device create command encoder. Oh, it's capitalized. That's what you get for writing a lot of code without checking anything. Clear color, the name of the property. And we crashed. That's good. Okay, now let's see why we crashed. We crashed and get current texture view. Why? Get current texture view. Maybe are we not initializing the thing? Possible. Because I don't do any checks at all. Yeah. Okay. Should be here. Always initialize the thing. Oh, and now we get a proper error. This uses a macro that I also have here somewhere. Oh, where would that be? Window. This is basically a macro to shorting. Very common idiom where you have like in C. Let me see if I can write this right. In C, you have something like something pointer equal blah equals pointer to struct blah, right? Anonymous struct. And in scopes, you don't have that, but you can make it with a macro. And I don't remember where I put it, but I use it somewhere using import column. Maybe here? No. Here it is. This macro right here. And I think, where did I use it? I could have been using it for all these descriptors instead of having it the variable declared right above and then passing a pointer. But I was hoping I wouldn't have to use this right now. Okay. Here. Okay, so we want to put this here. Okay, up here. Okay, now we have another error. Oh yeah, we can't change that pointer. I said we might have to do this. So like we're doing a forced question or forced casting instead of implicit casting. Hmm. Oh, I guess this is already a pointer, so we don't need to do this. Oh, I think you need to dereference it. Oh boy. I think that's really big. Right? No. It's kind of confusing. This is probably not what you should do either. No, this is wrong. Let me see what's real again. This is a pointer to a pointer, and we're getting a pointer to the thing. Hmm. Okay, how do I do this in the in here? It's probably like one line thing. Oh, I don't need any of this complicated stuff. So instead of this stuff, forget this as well. So like just do this. Device. Okay, so now we have another. Oh, and now we don't have this thing. So I guess we can't create an instant yet. So like forget this. And where it asks for an instance, you pass no. That's what I was thinking about earlier. Okay. And now we have a thing that works. Here's a color, although it's black and we wanted it to be white. So something's happening here. Like clear color. What's the clear color? Hmm. I mean, it kind of works, but it's not clearing. I don't like that, but like it doesn't have the problem that it had before where it wouldn't update the window, right? Maybe I did this wrong. Oh, um, oh, I could end the video here, but I want to figure out why this is changing the color. Maybe it's the load OP star OP thing. But some of these stuff is so you never really know what you're supposed to use. I mean, I probably would know if I knew, but I don't know. You know what I mean? I think I don't even use it. Okay, so I guess I'll just cross-check my code. Follow attachments, one. And I guess this changed. This is exactly the same as well. Usage format width, height, present mode is the same. I have no idea why it isn't working. That's good. You submit. Did I do this wrong? I guess. Oh, I'm not sending my comment buffer. Okay. Here we go. Good thing I let myself look up stuff. And I guess it's one command. Oh, this is the count of comment buffers, even if it doesn't have any comments. Okay. All right, and it works until it doesn't. I will investigate this crash later. Unable to present swap chain device lost. Okay, now we know it crashes. Like, yeah, sometimes it doesn't like that. I think what I need to do here is to hook the swap chain recreation to the window resize callback instead of doing it here, I think. But I also think this is kind of an Intel thing. I don't know. Sometimes it's kind of annoying. We'll see. It's probably safer if I do it in the, is that even how I, yeah, that's totally how I check it. Anyway, this is enough for today. I will go back to setting the color properly here. It should be still white, and then the color I actually want is this. Great. So now we have this dark gray color. As you can see, it kind of takes a while to get started with WebGPU, but it really should be getting more interesting from now. No more weird stuff in initialization, although when we get to textures and stuff like that, there's still a lot of descriptors to go, but it'll be fun, probably. So thanks for watching, and I see you next part.